The engine nose cowl anti-icing system prevents ice formation on the nose cowl and T2 probe. 14th stage bleed air is taken from the associated engine, reduced in pressure, and used to heat the nose cowl and T2 probe. Components of each cowl anti-ice system include 14th stage bleed air valve, cowl anti-ice valve, pressure relief valve, anti-ice ducting. 2 cowl anti-ice switches are located on the anti-ice control panel. 14th stage bleed air valves. 14th stage compressor air is bled from the engines by opening the left and right 14th stage bleed air switches. Very hot bleed air is delivered to the cowl anti-ice valves. Cowl anti-ice valves. The cowl anti-ice valve is a pressure-regulating shut-off valve. The valves modulate between open and close. This modulation reduces the high 14th stage air pressure to the level needed to anti-ice the nose cowl and T2 probe. The valves are fail-safe to the open position. If electrical power is lost, the cowl anti-ice valves will open and cowl anti-icing will operate. Cowl anti-ice ducting. Hot anti-ice air is supplied from the cowl anti-ice valve and ducted to the engine fuel control T2 probe and nose cowl. Anti-ice air is directed to an ejector, then sprayed onto the inner surface of the cowl leading edge via a piccolo tube. After completing the anti-ice process, the air is discharged overboard through a louvered panel on the bottom of the engine nacelle. Pressure relief valve. The pressure relief valve provides the cowl anti-ice ducting with overpressure protection. Should the pressure regulating function of the cowl anti-ice valve fail, system pressure is dumped overboard through the pressure relief valve. A round-shaped plunger protruding from the left side of the nacelle identifies that the pressure relief valve is open. Resetting of the valve is a maintenance action. Note: during the walk-around inspection, the pilot must visually check that the plunger is not extended. Thrust reverser override protection. The thrust reverser system has priority over the cowl anti-icing operation. The thrust reversers and cowl anti-ice both utilize 14th stage bleed air. To ensure that sufficient bleed air is available to activate the reversers, the cowl anti-ice valves are automatically closed when the thrust reversers are operated. When the thrust reversers are stowed, cowl anti-ice resumes. Normal system indications. When the cowl anti-icing switch is selected to on, the ICAS indications displayed are as follows. Green flow lines displayed on anti-ice synoptic page when cowl anti-ice pressure is normal. Cowl anti-icing valve shown in open position. On the anti-ice synoptic page, the position of cowl anti-icing valve is a function of the commanded switch selection. It does not necessarily represent the actual position of the valve. Unlike most other pneumatic valves used on the regional jet, The cowl anti-icing valves cannot provide actual valve position data to the ICAS. The cowl anti-icing valves on the anti-ice synoptic page are represented by the color cyan and labeled CMD. Abnormal system indications. Cowl anti-icing malfunctions are indicated by an amber left or right cowl anti-ice caution message. If the message appears when the system is selected to on, the system has not reached operating pressure. If the message appears when the system is selected to off, the cowl anti-icing valve has failed in the open position. The amber left or right cowl anti-ice caution messages are inhibited during thrust reverser operation.